Welcome back, everyone. Ready for another deep dive? This time, we're heading into the world where nature's designs meet cutting-edge tech.
Always an exciting intersection, that's for sure.
Absolutely. And we've got some pretty incredible research to dig into today, fresh from the University of Illinois Granger College of Engineering. It's all about a new 3D printing technique.
Oh, 3D printing is always pushing the boundaries. What's this one all about?
Get this. Scientists are now able to actually recreate some of nature's most complex structures, and I'm talking super intricate stuff.
Like what? Give us some examples.
Things spider silk, those super sensitive sensory hairs, even, wait for it, hagfish slime.
Hagfish slime. Wow, you were kidding about pushing boundaries. No, that's something I would have expected. What makes it so special that scientists are trying to recreate it?
Well, as icky as it sounds, hagfish slime has some seriously cool properties that scientists have been trying to, well, mimic for ages. Why don't you tell us a little about those properties?
Okay, so picture this. Hagfish slime. It's incredibly strong, super flexible, and it can soak up a ton of water.
Now that's a combo. I'm already starting to see some potential applications here.
Right. I mean, think about something like a bandage. What if we had a bandage that could perfectly mold to any wound?
And absorb all that fluid.
Exactly. Plus provide that crazy strength and flexibility we were talking about?
Okay, I'm convinced. Hagfish slime is way cooler than I thought.
Right. And that's just one example. We're talking about a whole world of potential here.
I bet. But I'm guessing actually making something as intricate as a hagfish slime thread isn't exactly a walk in the park, is it?
Not at all. Traditional 3D printing, it's great for a lot of things, but it has limitations.
Yeah, the whole building things layer by layer thing.
Exactly. That could be slow, and you often need those support structures that have to be taken out later.
Yeah, those pesky supports. Not ideal when you're dealing with something as delicate as, well, slime threads.
Right. For larger objects, it's fine, but when you're trying to get down to the microscopic level, it just doesn't cut it.
So how did these researchers at Illinois overcome those limitations? They came up with this new technique called embedded 3D printing, right?
You got it. And it's a pretty clever approach. Instead of printing in the air, they essentially print within a supporting gel medium.
Interesting. So the gel kind of acts like a mold.
It's a great way to think about it. The gel allows the printed material to take on these really complex shapes.
Without collapsing on itself.
Exactly. Keeps everything nice and supported. But wait, there's more. They've also incorporated this solvent exchange process into the mix.
Solvent exchange. Okay, lay it on me. What does that do?
It's kind of magical, actually. The printed material basically solidifies super fast, like almost instantly, when it hits the gel.
Whoa, so it's like an instant hardening process. I can see how that would be helpful, but how does that tie into overcoming those limitations we talked about?
Well, think about surface tension.
Surface tension. Remind me again what that is exactly.
Surface tension, it's what causes liquids to bead up, like when you see water droplets on a leaf.
Oh, right.
So in normal 3D printing, when you're dealing with superfine filaments, surface tension can cause them to break apart before they can solidify.
I see. So they kind of just disintegrate.
Pretty much. But with this solvent exchange, the material hardens so quickly that surface tension doesn't have a chance to mess things up. And that's how they're able to make these unbelievably tiny fibers.
How tiny are we talking?
Try 1.5 microns in diameter.
Whoa, 1.5 microns. To put that in perspective for everyone listening, a human hair is about 75 microns in diameter.
Exactly. So we're talking about something almost 50 times smaller than a human hair. And here's the kicker. They used this method to successfully recreate, you guessed it, hagfish slime threads.
No way. They actually managed to recreate those threads in the lab. That's amazing. So now that they've done it, what's next? What can we actually do with these microscopic hagfish slime threads? I mean, we've already talked about bandages, but what other possibilities are there?
Oh, well, hagfish slime, that's just the start. The really exciting part is that this technology, it opens up so many possibilities for recreating all sorts of other natural structures. Think about spider silk, for instance.
Oh, yeah, spider silk. That stuff's legendary. Super strong, crazy lightweight, and stretchy, too, right?
You got it. And imagine being able to create synthetic spider silk, but with this incredible level of precision.
Okay, now you've got me really interested. What could we actually do with synthetic spider silk that we can't do with the materials we already have?
Well, just imagine things like lighter, stronger aircraft components. Or what about cables for bridges? They could be both incredibly strong and flexible.
Wow, those are some serious applications.
And that's not all. Spider silk showing a lot of promise in the medical field, too.
Oh, right. I've read about that. They're using it for things like sutures, even as scaffolding for tissue engineering.
Exactly. And with this new printing technique, well, who knows what we could achieve in terms of biomaterials. Imagine printing structures that actually mimic the way natural tissues are built.
That would be incredible. Better integration, faster healing.
Precisely. It's pretty mind-blowing stuff.
Okay, so we've got aerospace, we've got medicine. What about electronics? Could we use this tech to make new kinds of sensors or electronic components?
Absolutely. The ability to print such fine features, it could be huge for electronics. Imagine flexible circuits that could be integrated into clothes or even directly onto the skin,
Wow, talk about wearable tech.
right? And sensors. Don't even get me started.
Haha, okay, get started. Tell me more about the sensor possibilities.
Well, think about it. We could make sensors that are so small and sensitive, they could detect the tiniest changes in the environment.
What would that mean in terms of real-world applications?
Oh, all sorts of things. Super precise medical diagnostics, advanced environmental monitoring systems, even better robots that can really sense and respond to the world around them.
It's like opening up this whole new world of sensory perception. We could gain insights that we never thought possible.
Exactly. And that's what's so cool about this field. We're not just blindly copying nature. We're trying to understand the basic principles that make natural structures so effective.
So it's like looking at nature's blueprints and then using that knowledge to design and engineer even better materials.
Precisely. And by studying things like hagfish slime threads or spider silk at the microscopic level, well, we can learn a lot about how to build materials with those same amazing properties.
It's like we're taking biomimicry to a whole new level. It's more like bioinspiration, right? Taking those cues from nature and then pushing the boundaries even further with our own innovations.
You got it. Combining the wisdom of nature with the power of human ingenuity, that's where the real breakthroughs happen.
Okay, so this research sounds incredibly promising, but I'm guessing there are still some challenges to overcome, right? What are some of the hurdles researchers are facing?
One of the big ones is scaling up production. Right now, this is mostly happening in labs. To make it commercially viable, we need to figure out how to produce these materials on a much larger scale.
That makes sense. What about the materials themselves? Are we limited in terms of what kinds of materials we can actually use with this printing process?
That's another area where there's definitely room for improvement. Right now, researchers are working with a fairly limited set of materials. To really unlock the full potential of this tech, we need to expand that range.
So there's still a lot of work to be done, but the potential benefits, wow, they're pretty amazing. It really does feel like we're just scratching the surface of what's possible.
Absolutely. It's an exciting time to be following this field. The possibilities really are pretty much endless. Who knows, maybe one day we'll be printing materials that are as strong as steel but light as a feather.
I love it. Or electronics that are seamlessly integrated into our bodies.
Exactly. And that's the beauty of science, right? It just keeps pushing those boundaries of what we think is possible. It opens up these whole new frontiers of knowledge and innovation.
Well, I'd say this deep dive has definitely been eye-opening. I am super impressed with the potential of this technology. It's like we're witnessing the birth of a whole new era of bio-inspired materials and tech.
Couldn't agree more. It really highlights how important it is to learn from nature and figure out how to replicate its incredible designs.
It's not just about creating cool gadgets either. This tech has the potential to make a real difference in the world.
Absolutely. And that's what gets me really fired up about this. It really does. Like we were talking about earlier, think about those sensory hairs that help insects navigate and sense their surrounding. What if we could replicate those?
Oh, wow, yeah. Imagine the possibilities if we could create sensors that are just as sensitive.
It would be revolutionary. We could have incredibly precise medical diagnostic tools.
Oh, yeah, that makes sense.
And what about environmental monitoring systems that could pick up on even the smallest changes?
That's a great idea. Or even improving the way robots interact with the world, right?
Exactly. Giving them a whole new level of perception.
It's like we're talking about giving machines a sixth sense.
And that's what makes this field so fascinating. It's not just about copying nature. It's about learning from its designs and then going even further, taking those building blocks and creating something completely new.
Right, so it's not just biomimicry, it's bioinspiration. We're taking those cues from nature and then using our own creativity to go beyond what nature's done.
Exactly. Combining the best of both worlds. The wisdom of nature and the power of human innovation.
Well, I have to say this deep dive has been truly amazing. I'm blown away by the potential of this technology.
Me too. And we're really just getting started. Imagine what we'll be able to do in the future.
It's so exciting to think about all the possibilities.
If anyone out there wants to learn more, I highly recommend checking out the world of biomimicry and 3D printing. There's so much to explore. Who knows, you might even be the one to come up with the next big breakthrough.
That's a great point. Inspiration can come from anywhere. Well, unfortunately, that brings us to the end of our deep dive today, but I want to leave everyone with one final thought. If we can now print something as intricate and delicate as a spider silk, Jim, imagine what else we might discover in the future.
What other secrets does nature hold? It really makes you wonder, doesn't it?
It sure does. There's a whole world of possibilities out there just waiting to be discovered. Thanks for joining us on this incredible journey of exploration.
Until next time, keep exploring, keep asking questions, and keep that sense of wonder alive.